Acids are molecular compounds, but because they contain hydrogen, before now we tended to use the ionic naming like hydrogen chloride. However, when we are talking about acids, we do have specific naming practices. Looking at naming acids, we have binary acids and what are called oxaloacids. Binary acids are very simple. They are going to be acids that have a hydrogen, because all acids have a hydrogen in it, and it's going to be followed by a non-metal for the periodic table. So what we do is we're going to take the hydro from the hydrogen, the anion root, the basic name. Instead of saying IDE, we're going to replace the suffix with ic acid. One of the most common acids, HCl, we would have named this based off its molecular name, hydrogen chloride. However, being an acid, it needs to be identified as an acid. Therefore, we're going to take that hydro, so the root of hydrogen. We're going to take the root of the anion, chlor, so it's chlorine, chloride, chlor. And instead of "ide," we say ic acid. This gives us an idea that we are working with an acid. It's going to have very distinct properties over the molecular name. Do this with any other simple binary acid, hydrobromic acid, hydrofluoric acid. We just bring them all together. When we were working with ionic naming, we had our polyatomic ions. Some of those polyatomic ions are called oxyanions because they had oxygen as part of the polyatomic ion. Well, so these oxyanions form oxyacids. What this looks like is we will have a hydrogen with that polyatomic ion. When that oxyanion has a certain number of oxygens, it's going to have the ate versus the ite. And that helps us distinguish which oxyanion or polyatomic ion we are working with. We do the same with our acids and bases. Looking at our ates, so hydrogen with an 8 polyatomic ion. We are going to take the oxyanion root and then just add ic acid. Big change here, we don't put hydro in with this. H2SO4. One of the most common strong acids there are. The molecular name would have been hydrogen sulfate. I can spell. When we're looking at the acid name, we ignore hydrogen. We take the oxyanion root, sulf, and this becomes sulfuric acid. Phosphoric acid. Nitric acid. All right. We do add that UR back in because sulfic just sounds funny. So we do say sulfuric. We put the whole word back in, but we have that root there. For our ites, the oxyanion root, and it becomes us acid. So here we have HNO2. Molecular name would have been hydrogen nitrite. We ignore the hydrogen. We take the oxyanion, and this becomes nitrous acid. So the ic versus the us distinguishes between how many oxygens we have if we're working with the 8 oxyanion or the ite oxyanion. Remember, you do have the polyatomic ions in your chem data sheet, so you just need to remember how to add the acid name of that oxyanion root, and whether it's ic acid or us acid. Naming bases is so much more simple because it's ionic naming. A lot of bases we work with in inorganic chemistry is going to be an ionic compound. It's going to be a metal with a hydroxide ion. That hydroxide ion is what gives the properties of the base. Here we've got NaOH. We name it as we have learned with ionic naming. It becomes sodium hydroxide. Lithium hydroxide, barium hydroxide, calcium hydroxide. So we've already learned those namings with ionic compounds. There's a whole other group of bases that are organic compounds. You'll learn more about these if you continue on to organic and biochemistry. What we look for is a nitrogen-hydrogen group on an organic compound. The most common inorganic base that is a molecular one is NH3. This is ammonia. It is the base for ammonium, the polyatomic ion. You do need to recognize ammonia, and that is going to be a base. That's the only one you need to be able to name and use. But for practice, you may see some other organic bases. So an example is you could have CH3NH2. Here's that carbon-hydrogen compound like we have talked about with combustion reactions. But more importantly, we have that amino group, that nitrogen-hydrogen group. Not asking you to name these, but just notice that it's the nitrogen that acts as that organic base.